Welcome, Data Lords! Today we are going to delve a little bit in the matrix factorization world, and to do that we are going to implement from scratch matrix factorization using PyTorch, and also we are going to use the renowned Movielens dataset, so let's do it. So for the first step, we are going to be setting up the environment. So to do that, we're going to create a code environment, install all the libraries that is needed, fire up Git, and let's jump into code. Before we dive into the details of data.py, we have a little issue with our dataset, is that the fact that not every move ID and not every user ID have associated ratings. To do that, we are going to be transforming the user ID and the movie ID columns into different column, already normalized, because we don't want to process it in runtime. It's going to be really expensive. So finally, we're going to test it. We are going to use the name equals main to test this file and check whether it's returning correctly or not. Now let's talk a little bit about matrix factorization models. Here we're going to extend the nn.model class from PyTorch and setting up two embedding matrices, one for user and another one for movie. You can think this model as trying to translate a user and a movie into a numerical representation in a way that we can measure distance between those entities. So if two movies are really similar, we can check this by calculating the distance between those two movies, and they are probably going to be a low value. Another thing that is important to mention is about the embedding size, which is how many numeric values we are going to use to represent a user and an item. This number is important to dictate how complex are the representation or not, and is a really important parameter to experiment and try out different values and check whether it is improving or not, and all of that. Here for the train.py, we're going to use a standard procedure that is splitting up the dataset into train and validation loop and trying to measure the loss in the train part and also in the validation part in a way that we can see if the model is generalizing or not. To do that split, I use a generator to maintain the seed of the split, so in a way that we don't actually take different data sets if we run multiple times. For the batch size, we can use a really large number because our instance is lightweight, just 3 float point numbers, and that's great. So let's use a really high number to improve the time that is needed to train. So for the optimizer, I choose MSE, but we don't have to stick with it. Maybe we could choose RMSE or maybe MI. And the great thing about MSE and also with RMSE is because they penalize more outliers and try to stick the data closely. For the validation loop, it is important to disable the training of the model because we don't want to first use unnecessary resources and also leaking the validation dataset into the model. So we are going to disable it with .eval and then re-enable the training as .train and zero grad and all of that to do the training. For this video, I skipped model evaluation, but it's really important if you're going to be deploying in a production environment and all of that. And I suggest you to search for the top-end metric, which is a metric that when you find a positive rating, they predict the dataset and try to find if the positive rating is in the top end window, and it is a metric that is really used out there, so keep track on. To check whether the model learned something or not, we are going to be selecting the neighborhoods of some movies that I choose, and to do that we are going to measure the distance between all movies and the movies that I selected, and we get the top 5 closest one. One thing that is really important to mention here is when loading the model, we have to stick with the parameters that you use it during training. And if you're not, they probably are giving you errors, and so keep that on mind when trying to load the model. To get the name of the movie, we have the movie.csv file, will help a lot with the mapping part. And we just need to remember that we encoded those indexes right into the data.py file, and we need to decode it before using the movie.csv. And there you have it. We made it. We implemented a matrix factorization from scratch using PyTorch and the Movielens dataset. Feel free to dive into the code, experiment with embedding size, try different optimization algorithms. And thank you so much for your time. Hope you have learned something new today.